All right, welcome to Chapter 2, Part 6 video. This is the final video for Chapter 2. So after this, we will have a review day, and then it will be the test. So make sure that if you have any questions from anything throughout the chapter, you are setting up office hours. The sooner the better, because then you have time to kind of think it through and make sure that it makes sense before we take the test. Once I assign the test, there will not be office hours regarding this chapter, because that would just be too hectic of trying to set up everything over a weekend. So if you have questions, make sure that you ask them in class or set up office hours. Our last part of this chapter is looking at putting together a lot of the components that we've been looking at. So inequalities, but now we're going to graph inequalities in two variables. Just like lines, we started out graphing points on a number line. We started out graphing inequalities on a number line. Now we're going to look at inequalities in a two-dimensional plane, in a coordinate plane, like we've been graphing lines on. And then we're going to apply that to a situation and look at what happens to those inequalities if, instead of looking at linear inequalities, if we look at absolute value inequalities. So we're going to look at inequalities in a few different ways. First, let's do kind of set ourselves in the mindset of absolute values. So we have a gift card for a store that sells pre-owned CDs. I said absolute values, I meant inequalities. Okay, so we have a gift card for a store that sells pre-owned CDs and paper books. You want to spend as much of the gift card as possible. How many of each item can you buy? So the first thing to notice here is you want to buy something, right? I can buy a CD, I can't buy half of a CD, right? So even if I could buy 1.9 CDs, I can only buy one CD. I don't have enough money for that second CD. So that's going to come into effect when we get to the kind of end of this question. So let's take a look. You have a gift card for a store that sells pre-owned CDs at $5.25 each, as we see over there on the right, and paperback books at $3 each. You want to spend as much of your gift card. Our gift card is $50, as shown in the picture. How many of each item can we buy? Well, we know that we can buy CDs and books. So let's let X represent the number of CDs we can buy, and Y can represent the number of books. Step one, I had to say, what is the question that I'm being asked, and how do I respond to that? So I need to know how many CDs and how many books. So those will be my variables. And then we need to find a relationship. So if I'm buying CDs, they're $5.25 each. So the cost of all of my CDs together will be $5.25 times however many CDs I buy. But I'm also buying books. So that's going to be $3 for each book times however many books I buy. And we want this to be under $50. So I can spend equal to $50, or I can spend less than $50. I cannot spend more than $50. So the amount I spend has to be less than or equal to $50. So we have an inequality here. So how many of each of these can we buy? Well, if I buy a certain number of CDs, then I won't be able to buy as many books. And if I buy a certain number of books, then I won't be able to buy as many CDs, right? I know that I have to have less than 10 CDs. Because if I try to buy 10 CDs, that'll be $52. I can't buy 10 CDs. So what if I buy 9 CDs? Then will I have any money left over for books, right? So this is the type of question that we're going to solve. And the way that we end up solving this is if we graph this line, 5.25x plus 3y equals 50, we'll be able to look at which solutions are under 50 and which solutions are over 50. So by looking at the boundary of what would equal 50, we can look at, okay, so then if I want to spend less than 50, all of these solutions would work. And there's more than one solution, right? I could buy one CD and one book. That would definitely be under $50, but that's not using the most of my gift card, okay? So let's practice. If I wanted to graph this line, I want to solve for y. So I would say 3y equals minus 5.25x plus 50 by subtracting from both sides. And then I want to divide by 3 on both sides. So y equals negative 5.25 over 3x plus 50 over 3. And if we put that into our calculator, we would get that y equals negative 1.75x plus 16.66 repeating. Well, I don't do the 7 and the repeating, just one or the other. Okay, so if I graph this, I'm going to go up to 16.66 or 16 and 2/3 with a slope of negative 1.5, something like this. Again, I'm just sketching. Okay, so since I want my gift card to be able to cover the cost, I know that 0, works, right? I can buy 0 CDs and 0 books. I have enough money for that. So that tells me that this whole triangle here, let me try that again. I colored outside the lines. Okay, here we go, that's better. This whole triangle here gives me my solutions. Now, I can't buy a negative number of CDs or a negative number of books. That's why I'm not coloring in any of the other 3 quadrants, because I can only buy a positive number or 0 of the CDs and books. But again, I can't buy part of a book or part of a CD, so only the integer values. And because these are all positive, we actually can describe it as whole number values. So let's take a look at the lesson here. So we already kind of we've seen a lot of these components in that example. We're going to formalize it, and we're going to look at some examples that we're actually going to solve and find our answers to. Okay, so our first vocabulary is, what's the difference between this inequality and the one that we were using before? Well, this inequality has 2 variables. Before, we were looking at things that had like x is less than 2. That's only 1 variable, okay? And so I can draw just an x-axis, and I say, here's 2. If x is less than 2, it's all of these values. It's only 1 variable that I had to worry about. Now, if I say something like y is less than 2x, well, now I have 2 variables. So I need a y-axis and an x-axis. And then in order to solve this, I have to say, well, where is 2x? So in order to find the solution to an inequality, we have to use what's called a boundary. And that is to say, where would they be equal? And therefore, we can find where they will be greater than or less than. Okay, so y equals 2x is a line that we know how to graph. That would be this line with a slope of 2 through the origin. Okay, but notice this does not have an or equals to, and so then we would have to write it as a dashed line. Okay, now if you write it as a solid line, you can always go through with your eraser and erase little parts of your line, or you can just draw over it in a darker color and draw it as a dashed line. And just like an open circle, when we were graphing, an open circle was not included in our answers. The points that are on this line will not be included in our answers. So if it has the or equals to, that's like a solid dot or a square bracket. If it doesn't have the or equals to, that was an open circle or a parenthesis. So now we can expand that to say solid dot is a solid line. An open circle is a dotted or dashed line. Okay, and then once we have that line, we're going to pick a test point. So if I'm looking at y is less than 2x, I don't want to pick a point that's on my boundary line. If I pick 0, 0, because that's on the dotted line, I know it shouldn't work. 0 is not less than 0, right? But I can pick another point, any other point. So let's pick 1, 0 and see if that works. So we're substituting it into the original equation. X is 1, so that's 2 times 1. Is that more than y was 0? Is 0 less than 2? Yes, 0 is smaller than 2, so we would shade this side. Now, why am I shading part of my plane? Any point in that shaded region, just like filling in a circle means that that's part of our answer, filling in a region, in this case, half of our plane, says that any point that's shaded in is a solution to our equation. So I can pick any point in here. I can pick this point, it would work. 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 If I pick this point, it will not work. That's not in my shaded region. So that shaded part is called a half plane, because we took the plane and we're only looking at part of it. Now, eventually we'll get to the point where we're cutting our plane into more than just 2 pieces. Maybe we'll cut it into 4 pieces. And even if we're only taking one of those pieces, it's still called a half plane. So even if I have my axes here and I end up with, oh, something like this, and I have my answer is only part of it, and that's what we'll get to eventually, not this lesson. But if I have something like that, that region, even though it's like a quarter of the plane, is still called a half plane because half planes are infinite. Okay, now in Math Excel, when you're doing these problems, you will be given the axes, and then you're going to draw in the line. And then in order to fill in half of your plane, you have these little paint buckets. Close. Okay, so when I'm talking about filling in your half plane, sometimes I'll use the word like, where would your bucket go? Because I'm referring to how you've been doing it as practice on Math Excel. So if I say something like, where is your bucket? Or you have too many buckets, then that means that you are looking at the wrong half plane. Or in Math Excel, if you put 2 buckets on the same half plane, even though it's filling in the correct area, if you have 2 buckets there, it will still mark it incorrect. Okay, so you only need 1 bucket to fill in a half plane. That's what I use the word buckets to describe. That's the method that you would use on Math Excel. Okay, so let's take a look at an example. Graph y is greater than 3x plus 1. So we said our first step is to say, well, in order to find out what's greater than, I need to find out what's equal to, so that I can say everything bigger than that is greater than. So our first step is to change it to an equation. Y equals 3x minus 1. And then we're going to determine if it's solid or dashed. Solid, like a solid circle, dashed, like a hollow circle. So will this be solid or dashed? There is no or equal to, so this will be dashed. No or equal. Only are greater than or less than or equal to are solid. Okay, so graphing this line, I go down to my y-intercept of -1. My slope is 3, so rise 3, run 1. There are my points. Now I'm going to draw my line. Let me try that again. That's a little bit closer. Okay, so there's my line, but I want it to be dashed. So I'm going to go through and with a darker pen, I'm going to make sure that it's clear that this is dashed. Okay. Now, if you have a dashed line over a solid line, I'm going to assume that you mean that that is dashed. And so if you do a dashed line and you want it to be solid, you have to really make sure that you go over it again and make sure that it's solid. Or as a backup, you can always say dashed, or you can say solid. Okay. If you're concerned about making sure that it's solid or dashed, what you can do is before you draw in the line, after you draw in your points that you're going to connect, say, oh, this is going to be dashed. Then I'm going to draw it the first time originally just as a dashed line, connecting kind of those dots. Now it has to be connecting enough that it looks like a straight line. I can't just do like, that's my line. Those are too far apart. Okay. It has to look like a line that's just been broken up a little bit. Okay, so there's my dashed line. Now I need to find out which side of the line am I going to color in. Is it going to be to the right or to the left? Is it going to be above or below? Now, every single time, it's going to be a different answer, okay? So there's no surefire if it's a greater than, you're coloring to the right. If it's a less than, you're coloring to the left. There's no surefire way to answer that, okay? There are a lot of patterns that you will see, but the only way that will work every time is to test a point, okay? Now, if 0, 0 is not on my line, that's the best number to test because 0 just, it's easy to calculate, right? Now, if I'm looking at my graph, my y-intercept was -1, so that means 0, 0 is not on my line. So let's go ahead and test 0, 0. So if x is 0 and y is 0, we get 0 is greater than 3 times 0 minus 1. Is 0 greater than -1? Is 0 bigger than -1? Yes, it is. 0 is going to be bigger than any negative number, and that means 0, 0 is a solution. That is colored in. And therefore, I'm going to color in that whole half plane. Okay, now it doesn't have to be fully colored. If you color it in like that on your worksheet, I will know exactly what you mean. Okay, and again, on Math Excel, all you're going to do, you're not going to color it in yourself. You're going to put a little paint bucket, and that will color in that half. Okay, I want to show you what happens if instead of getting a true inequality, what would happen if I get a false inequality? So instead of testing 0, 0, let's try testing a number on the other side. Let's try testing 2, 0. So if we test 2, 0, y is 0, and we want to know if that's greater than 3 times 2 minus 1. Is 0 greater than 6 minus 1? Is 0 greater than 5? No. So that tells me I'm not going to color in the right-hand side. I'm going to color in the left-hand side. So because this is false, I'm going to color in the opposite side. 2, 0 is not part of my solution, so it should not get colored in. And that's what would tell me to put my paint bucket on this side. Okay, so that's how we shade in the half plane. If it's true, we shade in the side with that point. If it's false, we do the other side. Okay, let's take a look at our next example. What is the graph of each inequality? So I'm going to do part A with you, and then I'm going to have you do part A as a try this. Okay. So for starting, our first step is to change the inequality into an equation. So step 1, y equals -2x plus 1. Step 2, is it dashed or solid? This has an or equals to, so this will be solid. So I'm going to plot my y-intercept. My slope is -2. -2, -2. Keep going with that -2. This is solid, so I'm going to go ahead and draw in my line. I don't have to make this dashed. It's just going to be a regular line. Step 3. Now that I have my border or my boundary, I need to determine which side am I going to color in, which half plane gets shaded. And so I'm going to pick in a test point. Now 0, 0 is not on my line, so let's test 0, 0. I'm going to write it 0, 0. I'm testing it, and that's why I'm changing this to 0 is greater than or equal to -2 times 0 plus 1. Is 0 greater than or equal to 1? No, 0 is smaller or less than 1. So it is not 0, 0. We are going to shade the opposite side. Okay. Since 0, 0 is on the kind of below side, the side that's lower and to the left, we're going to shade the opposite side, the side that is higher and to the right. Those are our solutions. If I pick any point on that half plane that we just shaded, I should get a true statement. So for example, if I picked the point 1, 1, let's just test it. Try this again. I'm trying to change colors. There we go. So if I test this, test 1, 1, I should be able to get a true statement. So 1 is greater than or equal to -2 times 1 plus 1. 1 is greater than or equal to -2 plus 1. Is 1 greater than or equal to -1? Yes. So that confirmed my answer. And then step 4, we already did it. Step 4 is to shade. Okay, try part B, and then we'll go through it together. So our first step, y equals negative 2x plus 1, so that I can draw the boundary. Our second step, determine if it's dashed or solid. There's no or equals to, so this is dashed. The y-intercept is 1. My slope is negative 2. This should feel familiar. The boundary is the exact same equation that we did in our previous example. However, this time our boundary is dashed. And then our step 3 is to pick a test point. Since it doesn't go through 0, 0, we'll try 0, 0. You only need to test 1 point. 0 is less than negative 2 times 0 plus 1. Is 0 less than 1? Yes, it is. So we are coloring in the side with 0, 0. And that is this side. Now, if we look at these two examples, we should be able to see why they're shading the opposite side, right? In part A, y was bigger than our expression. In B, y is smaller than our expression. So we should have opposite answers. All of these points that are shaded in part B have values less than negative 2x plus 1, have a y value less than negative 2x plus 1. Everything from part A has a y value greater than negative 2x plus 1. So we can kind of see how these are complementing each other, how they are similar to each other, but also why they're different. Okay, let's take a look at our next slide. Let's see, I might have just skipped a slide. Okay, so in this example, we are going to apply what we have just learned to see if we can solve a question very similar to what we were looking at the beginning of this video. So entertainment, the map shows the number of tickets needed for small or large rides at the fair. You don't want to spend more than $15 on tickets. How many small or large rides can you ride? Okay, so we know that tickets are 25 cents each. And we want to know not how many tickets we can buy, but how many rides we can ride, okay? So there's a couple things that we have to look at here. My $15 is not the same as 15 tickets, right? My unknown, X, I wanna know how many small and large rides I can ride. So X and Y are going to be my number of small rides and number of large rides. Okay, and then we have to compare those. Those are given to us in tickets. We need to compare those to money. So we have to determine, are we going to write our equation in terms of tickets or in terms of dollars? Now, if I write it in terms of dollars, we're gonna have a decimal, right? Because tickets are 25 cents each. So if we wanted to write them in terms of tickets, we won't have to deal with that decimal. So let's convert our dollars to tickets. $15 gets me how many tickets? Well, if each ticket is 25 cents, then I can buy 4 tickets for every dollar that I have. So I need 15 times 4, which is 60 tickets. Okay, so I have 3 tickets for every small ride, and I have 5 tickets for every large ride. And I need that to be within how many tickets I have. So that's less than or equal to 60 tickets, right? If I ride rides that would cost more than 60 tickets, then I'm broke. I would owe the park extra tickets, right? So I need to spend only up to $60 or 60 tickets. Okay, so step 1, I need to find the boundary line. So that's 3x plus 5y equals 60. Okay, we can graph this line. We can put it into slope-intercept form. We also know how to graph this line by finding its intercepts. Let's try remembering that way. Okay, so to find the intercepts, I would set x equal to 0 to find the y-intercept. and y equal to 0 to find the x-intercept. What happens when x is 0? We get that 5y equals 60. So y equals 12. Divide both sides by 5. What happens when y is 0? We have that 3x equals 60. Divide both sides by 3. We get that x equals 20. Okay, so my points here, I have 12, 0, 12, and 20, 0. Now that tells me we're not going to scale our graph by ones, right? Our graph isn't big enough for that. But what if we scale by twos? So if we scale by 2, our x-intercept will be at 20. Let's see if we have enough space for that. So we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. It's right on the edge, but that works. Okay, our y-intercept is at 12, so we've got 2, 4, 6, 8, 10, 12. And then we want to indicate that our scale is by 2s. Okay, we need to now determine, is this going to be a solid or a dashed line? This has an or equal to, so it will be a solid line. Okay, so I'm going to draw a solid line through those points. Step 3 is to test a point. Let's test 0, 0. So if I have 0 plus 0, is that less than or equal to 60? Yes, of course I can afford to ride no rides, right? So that tells me I'm shading in the lower part of my graph, okay? But think about what this graph means. Can I ride a negative number of rides? No. So really, we're additionally restricted by logic to say it's only possible to ride a positive number of rides. And so it's not really going to be that whole half plane. It's just this little triangle in here. And even more than that, so that was step 4, is to shade. Even more than that, I can't ride half of a ride. So the answer is really that I could ride no rides. I could ride 1 small ride. I could ride 2 small rides. I could ride 3 or 4 or 5 or 6, right? It's all of these points of integer values. So I could ride 12 large rides and 0 small rides. I can ride 20 small rides and 0 large rides, right? Or I can pick this point here. That's 2, 4, 6, 8, 10, 12 small and 2 large, right? I can also pick another point. Maybe I pick this point right there, which is 11 small and 3 large. So even though there wasn't a graph intersection there, because we counted by 2s, I can go between those grid lines as long as I'm getting integer numbers of rides, okay? So how many small and large rides can we ride? Well, we actually have a lot of different answers to that. And so our graph demonstrates the answer to that question. There's no single answer to this question. Okay, let's look at another example here. Now we're going to start introducing absolute values. Let me make sure I didn't skip something. No, okay. So absolute values are when we're graphing not a straight line, but a V shape, right? But in order to graph this, we're going to go through the exact same process as before. So remember our steps. Our first step is to change it to an equation. Y minus 4 equals 2 times the absolute value of x minus 1. What is our very first step to finish or to graph this is to get y by itself, right? In order to graph this, we're not solving for x, right? That could be a temptation here, is to try and isolate that absolute value so that we can solve for x, but y isn't a number. So this isn't going to give us a value. It's not going to give us an answer. It's going to give us an equation that we can then graph. So plus 4 on both sides. Y equals 2 times the absolute value of x minus 1 plus 4. So remember those transformations that we were doing, we're going to use them here. okay? We have a V shape. It has been moved. What does the x minus 1 do? It's inside of the absolute value bars, so it's going sideways. A minus 1 does the opposite. It's going to the right by 1. The plus 4 is outside of those absolute value bars, so it's going to move up by 4. And the 2 is a vertical stretch by 2. That's similar to slope, right? In this case, because of the absolute value bar is, or the absolute value graph is made up of line segments, it is the same as slope. So I'm starting at the origin. I go to the right by 1 and go up by 4, and then draw my absolute values with a slope of 2. Okay, step 2. Do I leave it solid or do I make it dashed? It has an or equals 2, so this stays solid. Step 3, I want to test a point. Now, this time, I'm not going to test a point on either side of the line. I'm going to test a point on the inside or the outside. So if we're looking at this absolute value, we can kind of see the yellow here would be the inside. It's inside of that absolute value. And then we can say that the green would be the outside of the absolute value. So I want to pick a point, but I'm not looking at one side of a line or the other. I'm looking at inside versus outside. Just like before, we're going to choose 0, 0 when we can because that's the easiest thing to compute. So 0, 0, and we're always going to substitute that into the original equation or inequality. So 0 minus 4 is greater than or equal to 2 times the absolute value of 0 minus 1. Negative 4 is greater than or equal to 2 times the absolute value of negative 1 is 1. Negative 4 is greater than or equal to 2 times 1. Negative 4 is greater than or equal to 2. Is this true or false? Is negative 4 bigger than 2? No. So 0, 0 is not in our solution. Then our solution is the middle. Okay, so this is an example of, even though it doesn't look like I'm coloring in half of the graph, that region is still called a half plane. And really, if I'm being precise, the shading goes all the way up to that line and should be completely filled in dark because all of those points are included in the solution. Okay, so graphing our absolute value, step 1. And then we're taking it one step further after that by shading in one side or the other, the inside or the outside of our absolute value. Okay, I think I have one more example for you. Okay, so I'd like you to try this one. Same steps as before, okay? Try it and then we'll go through it together. So our first step is to turn this into an equation. 1 minus y equals absolute value of x plus 2. All we've changed is the inequality into an equal sign. Now, because this is an equation, I want to solve for y. So I say minus 1, y equals the absolute value of x plus 2, whoops, negative y, minus 1. And I have to divide by negative 1, divide everything by negative 1. This is an equation. I don't have to worry about that inequality sign. Y equals negative 1 times the absolute value of x plus 2 plus 1. Okay, so now I want to graph this. The plus 2 moves it to the left by 2. Plus 1 moves it up by 1. This negative 1 is outside of my absolute value bars, so that is going to be a reflection over the x-axis. This is going to make it face downward instead of upward. Okay, so 2 to the left, 1, 2, up by 1, facing downward. Okay, step 2. Does it stay solid or does it become dashed? There's no or equal to, so this will be dashed. So what I'm going to do is either go through here and make it very clear that this should be a dashed line, or if you do step 2 before you draw in your line, you don't have to worry about that, right? Okay, step 3, test a point. Again, 0, 0 is not on my boundary line, so let's use that one. 0, 0 into the original equation. Now this is why we didn't have to worry about dividing by that -1 when it was an equation, because we are going to substitute, we're going to test our point into the very original, whatever the question asked us, not anything that we solved after that. So that's 1 minus 0 is less than the absolute value of 0 plus 2. That's 1 is less than the absolute value of 2 is 2. Is that true? That is true. 1 is less than 2. So I'm going to color in not just to the right, but everything on the outside of those absolute value bars. Okay, everything on the outside of the absolute value graph. And that was step 4, to shade. Okay, I think that was our last example. So we have 4 questions. Oh, I forgot to update this, just number 1 through 4 from the video. So just those 4 questions there are for homework. The copy that you have access to on Blackboard is already updated, as is the one that's posted on your Blackboard assignment. So number 1 through 4, that's all of the practice that you have for homework, and we'll do additional practice in class together when I see you.